Okay, identify and classify polygons and find the angle measures of quadrilaterals. So, a polygon is a plane figure that is formed by three or more segments. Three or more segments. This is a segment, okay? Put your phone away. Each side intersects exactly two other sides at its end points. Do it now. Okay, let's talk about this piece of paper. I'll wait till you guys are done writing. Does this shape meet the definition of a polygon? This shape. It's a plane figure that is formed by three or more segments. Okay, so this is formed by four segments, correct? Yep. Each side intersects, or here's a side, it intersects exactly two other sides, correct? Yeah. Okay? And at their endpoints. So this endpoint right here is called a what? Vertex. A vertex. More than one endpoint would be called what? Vertices. Vertices. See where that comes from? Okay, that's what that definition, this is the definition of a polygon. You could also have this. What's that shape?
Oh, it's a rhombus.
It's a trapezoid. And it does meet the definition. It's formed by three or more segments. Each side intersects exactly two other sides at the endpoints. Therefore, these are called what? What are those endpoints called, plural?
Vertex.
Vertex, individual, or vertices, plural. Okay? So, let me ask you this then. Is that a polygon?
No.
Why not?
Because this segment is...
Yeah, this is not a straight segment. Okay? All right. Diagonal of a polygon is a segment, means it has to be straight, a segment that joins two non-consecutive, wow, there's a word, vertices. What does non-consecutive mean to you? Anybody? Pardon me?
It's not healthy. It's consistent.
What does consecutive mean, do you think? Come on, somebody can say this. Somebody can answer it. What do you think consecutive means? Yes, thank you. Non-consecutive would mean not next to each other. Not next to each other. So let's look back up at our trapezoid here. Are these two vertices non-consecutive or are they consecutive?
Consecutive.
These are consecutive because they're next to each other. These are consecutive because they're next to each other. These two would be called what? Non-consecutive. Therefore, they can be connected by what we call a diagonal. This is a diagonal. Make sense? All right. Well, we did the vocab out of order, but let's just do the warm-up together. What is the sum of the measures of the interior angles of a triangle? You should all know this from last chapter. They add up to what? 180 degrees in any triangle. In which kind of triangle are all three sides congruent?
Equilateral.
Equilateral. Equal means equal, and lateral means side. Equilateral. Which kind of triangle are all three angles congruent? Equa means equal. Angular, they're talking about the angles. Okay? All right, so in this section, you just kind of have to define whether these are polygons based on our definition. So is this a polygon? A plane figure that is formed by three or more segments.
Yep.
Yep, it is a polygon. Yes. All sides are segments. Now I'm going to label this because we're going to add a little bit more to this picture. I want you to label it A, B, C, D, and E. I have a question for you. How many diagonals do you think are in this polygon?
Oh, I got it.
Why don't you connect and see?
Oh, I was looking at it.
Non-consecutive sides, there's a diagonal. There's a diagonal. There's a diagonal. Non-consecutive sides. It forms. Oh, there's another one I'm missing. What am I missing?
Yeah. It's D to B.
I did D to B.
E to-
I think it's just funny.
C to A.
A to C.
Oh, yeah,
You should have a star.
That's
Well, it's a little off. God, you guys are so unforgiving. Diagonals. Let's name the diagonals as segments. So let's start with segment, I don't know, segment AC is a diagonal. Segment AD is a diagonal. Then I'm going to go up to B. Segment BD. What's the other one coming off of B? BE. And then let's go over to C. I already named ACCA. They're the same segment, aren't they?
Yep.
Okay. I have not named segment CE. Let's go over to D. I already did BD, and I already did DA, so we're done there. Have we named them all? 1, 2, 3, 4, 5. I believe we have. Correct? All right. Is this a polygon? No, it's not a polygon. Okay? The segments have to meet at the vertices. These keep going. Okay? So because of this, it is not a segment. The sides do not meet at the vertices. They keep going here. Okay? Is this a polygon?
Yeah.
The segments are straight.
No, it's not. They're not all segments. Okay, they're not all segments because of the curve. They can't be curved. All right, turn it over. Let's see what you guys remember from elementary school. Oh my. I don't even know if we did it at middle school or not. I can't remember. All right, types of polygons. Let's see how far we can go before we get hung up
I
here.
didn't go to elementary school.
What do you call a three-sided polygon?
Triangle.
Very good.
Square.
Be careful.
Rectangle.
A four-sided is a square. It's also a rectangle, but we have a generic term for a four-sided polygon.
Quadrilateral.
Quadrilateral.
Stewie.
Four-sided. It could be a square, could be a rhombus, could be a diamond, could be a rectangle. So we have a general term for that. Five-sided. Pentagon. You all know the pentagon in DC, correct?
No.
Penta is 5.
I never went to DC.
6 is what? Hexagon. You may think of a witch's symbol is what? A hexagon. Hex. A hex. Hex and a witch. That's what I think of. Okay? 7 is tricky. It's not a sexagon.
Heptagon.
That would be fun, but it's not a sexagon. I always want to call it a septagon, but it's not a septagon. It's a what? Does anybody know?
Heptagon.
It's a heptagon. Why is it hepta? Don't know.
English language.
Octagon.
Yeah, you can think of octopus when you think of 8-sided. It's octagon.
Nanagon.
Yeah, 9 is close. Rory said it up here. What'd you say, Rory?
I'd say it.
Somebody, Jose.
Nanagon.
It's a nana, like your grandma. Does anybody call their grandma nana? Okay, nanagon.
I call her. She's dead.
Does anybody know what a 10-sided is? A decagon.
Oh, yeah.
These you're going to be responsible for knowing. If we go further than that, then you can just say this. 11agon. Isn't that weird?
12 gon.
12gon. It says 11-sided figure, polygon. 12-sided polygon. 621 gon.
Are you serious?
I don't know.
Oh, you
But you could.
How many sides is it?
Okay? All right. Decide whether the figure is a polygon. If so, tell what type. If not, explain why. So here we go again. Is this a polygon? Why? One side is not a segment. Okay.
Yes, quadrilateral.
Yes. Let's count. 1, 2, 3, 4. 4 sides. Therefore, it's a quadrilateral.
Octagon.
Yes, all the sides are straight and they intersect. 1, 2, 3, 4, 5. So it's a what? Pentagon.
I'm sexy.
Here's the first theorem on your pink sheet, right here. 6.1. Okay? The sum of the measures of the interior angles of a quadrilateral. What do you think? Let me draw you a picture here. Does anybody know what the angles of a quadrilateral might add up to?
230.
It says it, doesn't it? Does it say it?
360.
I hear 360. 360 is correct. Let me show you why. If I were to draw any kind of quadrilateral here, and I were to cut it in half, what two shapes are inside there?
Triangles.
Triangles, and you know that that's 180 and that's 180, right? So that any quadrilateral is always, all the angles are always going to add up to 360 because it's made up of two triangles. Courtney.
Yeah, but what about like the weird, like the pentagon right there?
But that's different. We're going to get to that. A pentagon is made up of more than two triangles.
Oh, right. We're just.
Okay, so we're just talking about a quadrilateral here. All right. Therefore, based on that knowledge, you got to find this unknown angle. All right? So this is my x. I need to know that measure. I know that all quadrilaterals add up to 360. So I have an algebra problem. Or a calculator problem once you write it out. Okay? So you combine all your like terms. So it becomes x plus 325 equals 360. Subtract 325 from both sides.
35.
And x would equal 35. So to be thorough, we would say the measure of angle angle V is 35 degrees. Okay? So that is that. You still have 15 minutes.